Welcome to our first video on solving equations. So we're now moving from expressions to solving equations. And this one will feel very familiar to what we did last year in 6th grade. The only difference is now we obviously have negatives to throw into the mix instead of just positive numbers. But go ahead and get your notes set up and then hit play to go on. So here are the rules that you need to have written down into your notes, and this is going to be the expectation of anything you do. Number one, anything you do to one side of the equation, you must do to the other. It always has to stay balanced or equal. So you remember from last year, we drew a line down through the equal sign to show us the two sides of the equation, and then we need to make sure we're showing the work on both sides of that. It's not optional. Second step is going to be the key for today. To solve an equation, you must undo whatever was done to the variable by using the inverse operations, which is really kind of doing the opposite. If they added, we subtract. If they multiplied, we divide. Kind of undoing whatever they did in the problem. And then the last one, you must show all of your work and you must do your check. The check's going to be really easy for these first lesson or two, but as we start to get into the more complicated equations, that check is going to become more and more important. So yes, both of those things are requirements for any one of these problems. So quick review, w plus 8 is equal to 13, so we want to know what w is. And it's fantastic that a lot of us can look at that and go, oh, w must be 5, because 5 plus 8 equals 13. But remember, solving an equation is about proving to somebody else how do you know that, and being able to find a mathematical way to work towards that solution, not just having a number appear. So whether you're a big fan of showing your work or not, this is what's going to be expected of you, and you'll see why even more as we get to larger and larger equations later on. But we always start with our variable, w. And we ask ourselves, what did they do to w? Well, they added 8. So to solve the equation, we need to get rid of that adding 8. We need to undo it. The opposite of adding 8 is to subtract 8. So I'm going to go ahead and subtract 8 from both sides. We had 8, but we subtracted it away, so that went to 0. So all we're left with is our variable, in this case, w. Over on the other side, we have 13 minus 8 is 5. In a simple problem like this, it's okay for that subtraction to be there. We'll see in some other examples where we have to watch for those kind of things. But if we can do a simple problem like 13 minus 8, we can just go ahead and leave that subtraction in there. Next one, 4x is equal to negative 8. So again, we draw our line down through the equal sign. And we ask ourselves, what did they do to x? Well, when 4 and x are right next to each other, that means they are multiplying. So we want to do the opposite, which is to divide. I like to show dividing using my fraction bar, but if you'd rather write it as with the division symbol, that's totally fine. But it's basically we have 4 of them. We divide it by 4. 4 divided by 4 becomes 1, so we're just left with x. Negative 8 divided by 4. Remember, a negative divided by a positive stays negative. 8 divided by 4 is 2, so x is equal to negative 2. Oop, forgot. I got to go back and do my check. All that means is we take our solution and plug it back into the original problem in place of our variable. So I plug in a 5 for w. 5 plus 8, is that really 13? It is. So we're good. Here, same thing. We're going to take our negative 2 and plug it back in place of our variable. So we just rewrite it as 4 times negative 2. Is that really negative 8? It is, so we're good. So let's try a couple more together. You can go as quick or as slow as you need to, but this is how I'm going to work through them. I always draw my line down through the equal sign because it reminds me of the two halves or the two sides of the equation that I need to keep balanced. They have to stay equal. Then I focus on my variable. What did they do to m? Well, they multiplied by negative 6. So the opposite is to divide by negative 6. Don't forget the negative when you're dividing. They multiplied by negative, so we divide by a negative. Negative 6 divided by negative 6 is 1, so we're just left with m. Negative 42 divided by negative 6. Negative divided by negative is a positive. 42 divided by 6 is 7. And then we do a quick check. Negative 6 times 7. Yep, that's negative 42, so I'm good. On this next one, when we see subtraction, you've got two options here. If you like just getting rid of that subtraction right off the bat, you are more than welcome to. But in a simple problem like this, it's okay to leave it as subtraction because we're going to do the opposite, which is adding. We'll kind of talk about when we need to watch out for those kind of things, but for right now, it's okay to leave that in a simple equation like this as a subtraction. But again, we ask ourselves, what did they do to y? Y, they subtracted away 6, so we want to put that 6 back. We're going to add it back, but we have to do the same thing to both sides. Subtracting 6 and then adding it back gets us back to 0, so we're just left with our y. Negative 6 plus 9 is going to give me negative 3. When I go to do my check, I'm going to plug my negative 3 in for y. Negative 3 minus 6. Here, since I'm actually going to go ahead and do the problem, let's change that subtraction to adding the opposite. Anytime there's a negative in the problem, we want to get rid of that subtraction. Negative 3 plus negative 6 is negative 9. That's what we wanted. So we're good. Down here, always start by drawing a line down through the equal sign. I know I'm going quick, but we'll be practicing a lot more of this together. Ask yourself, what did they do to x? Now, it doesn't matter that this is written in reverse order. It's still just adding 7. So if they added 7, I want to subtract 7 away. But I got to do the same thing to both sides. I had 7. We subtracted it away. So I'm just left with x. Here's where life is going to get a little bit complicated. If you see a negative in the problem, please don't leave subtraction in the problem. This is a case where if you try to do negative 8 minus 7, there's a good chance we're going to make a mistake with it. So when this number is negative, let's go ahead and change this to adding the opposite. Still the same problem, it's just a new way of writing it. But now we see that it's negative 8 plus negative 7. Two negatives we add together and keep the sign. So x is equal to negative 15. Don't forget your check. 7 plus x, so in this case negative 15. 7 plus negative 15, different signs, subtract them, take the sign of the higher number, so we really do get negative 8. So we're good. Last one. Your first instinct might be, ooh, this is a fraction problem, but remember it's not a fraction problem. Remember when z is over a number like this, it's really just a fancy way of writing dividing. Remember I used that fraction bar up here to show when I wanted to divide. So we ask ourselves, what did they do to z? They divided by 3, so I want to do the opposite. I want to multiply by 3. But I got to do the same thing to both sides. Multiplying by 3 and dividing by 3, 3 over 3 becomes 1. So I'm just left with 1z or z. Negative 15 times 3 is negative 45. Do my check. Negative 45 divided by 3. A negative divided by a positive is a negative. 45 divided by 3 really is 15. So I'm good. So every time we solve it, we're just doing the opposite. So now it's your turn. So at the end of our videos now, you're going to have a chance to actually show me that you know what you're doing. So copy down these problems. I want to see your line down through the middle. I want to see your work on both sides of the equation. What'd you get for your solution? And then don't forget to do your check. Okay, this is where you show me, have you been paying attention? Have you picked up on the steps? The only thing different from last year is gotta watch those negatives.